Hello, Frank. Hello, my friend. How's it going?
Hello, Denis. Hello, everybody.
Yep. And hello, absolutely everyone who is joining us live today. We appreciate that you decided to spend your time with us, the next hour with us. And I do believe that it's going to be a very fruitful session for you. Because as always, Frank and I, we prepared special samples and demos for you. Not only we are going to discuss DR, disaster recovery, and high availability in detail, but also we want to show you how to achieve DR and HA across multiple regions if you happen to write and build multi-region applications. So stay tuned and get ready with your questions. And in the meantime, Frank, as you usually suggest, me reminding, even though we have this primary topic for today, multi-region design patterns for HA and DR, you are highly encouraged to ask the questions that concern you. Like they might be unrelated completely. Just drop your question in the comments and they will make sure to address it today, or we will be able to connect our Slack one-on-one community Slack.
Yeah, or maybe it can be ideas for other sessions. And and in the chat also, if you can say just hello, and maybe we are streaming on a different day. Usually we do it on Wednesday, but I think it was a day off in US, and then we are doing it on Thursday.
Yeah, we had a national holiday yesterday, June 19th, and we just decided that let's just at least once try to do this event on Thursday and see how it goes. But also, folks, as always, those of you who watch us regularly, you know that we never start with the main topic. We try to give you an update on the recent news or something interesting that is coming in the world of Yugabyte or PostgreSQL. That's why the next 10 minutes, I think, we'll be discussing, what's coming and what you should be paying attention to. And in the meantime, what you need to do, if you want to learn something specific about DR or HA today, if you would like us to show something specific, just write down your comment, right? Write it down. We'll get a note of it and we will either just show it because it might be addressed by one of our examples, or we will just find a way how to explain it to you on fingers. Cool. Okay, so speaking about the news, Frank, let's start with you because you're not at the office, you're not at your home office.
Again, I'm at a conference, Voxed Days in Luxembourg, so developer conference, and next week I will be in Switzerland. Well, I live in Switzerland, but I will be in Zurich for the Postgres day in Zurich, so next week. So yeah, many conferences. And you?
And me, before talking about me, so folks, if you're at Works Days, absolutely. Frank had a presentation a couple of hours ago, but still he will spend the rest of the time at the conference, right? I guess.
And it's also the occasion. My talks are not always related to Yugabyte. It can be general SQL or databases or whatever, but conferences are a really good place to talk, to meet physically and talk about the topics we are excited about, distributed SQL, basically.
Yeah. So like if you're nearby today, or if you're planning to attend one of the events that Frank mentioned the next week, just find the time to meet him. Don't be it's going to be an excellent opportunity. He's a nice guy. I know. I think you met once in person. So yeah, speaking about me, next week I will be in Kansas City in the United States. If you live in Kansas City or planning to be there, then let's meet. On Tuesday, I will be speaking. I will be doing a deep dive into Yugabyte and distributed Postgres at the Kansas City Postgres user group. And that's on Tuesday. And then from Wednesday through Friday, I will be joining the Kansas City Developer Conference. So those of you who live in Kansas City or in the United States in general, you know that that's one of the major conferences for developers there. I will have a session. If you're interested, you will find me on the schedule. And the same, just stop by. Let's get to know each other and we can discuss like how you are going to use Postgres or YugabyteDB, and let's meet if you're nearby. So From that's from the conferences and events standpoint, and also keep an eye actually on our. Let me show you this. Keep an eye on our Yuga by DB Friday Tech Talks, because this week on Friday, tomorrow, we have a session about the new cost-based model that was introduced to Yuga by DB. It's still in the beta or early access mode, but with that model, Yuga by DB, like right now, is going to match the performance parity with Postgres, meaning that for distributed workloads, for single server workloads, let me show you the page so that you remember it. How do I share the screen? I do this.
Yeah, it's a huge step having a cost-based optimizer for complex queries. We had a rule-based optimizer that was good for basic OLTP queries, but now that we have more features, more possibilities in the execution plan, more optimization in the indexes, then we need a query planner that can take advantage of all that.
Exactly. The article is going to be released a little bit later, so stay tuned. We already have a wonderful draft of the article that is written by the engineer who contributed this new cost-based model. In the meantime, if you go to the community, you will find the Friday Tech Talks, and here is where is it? It should be upcoming talks.
I don't see it either. Yeah.
You don't see it
in the web page.
Yeah, let me go to the LinkedIn. Yeah, looks like there is some issue with the website page here. But if we go to the, so right now you see you see the events. Let me show you the events. Yeah, this one, performance improvements with their new cost models in Query Planner. So this one is excellent, good one. So if you have time tomorrow, stop by. So next, Frank, speaking about some of the news that also happened at the product level, you said that you are personally excited about those changes. Show us.
Yeah, also about performance, and yeah, we said that it's good to meet physically at conferences, but when there are no conferences, I'm on Twitter, and I like also to share what I discover on the new features, and that was just a screenshot about active session history. So the name, probably people who work with Oracle know the name. The idea is a different approach on tuning rather than performance metrics and counters and ratios. It is sampling the activity. And in Yugabyte, it's much more difficult because we have multiple layers and everything is multi-threaded. But just basically here, I was running some queries through pgbench with 5 clients, and I can see those 5 clients in the YSQL layer. They were all doing the same, waiting on storage, because this is what I was stressing. And we can see on the T server, the DocDB layer, we can see exactly the same activity, of course, that is behind. And this activity was just on CPU because I was really stressing cache reads there. But yeah, just saying that it will be a new way to troubleshoot performance, seeing exactly what happens when a query is long. And I think I have the documentation somewhere about the metrics. Maybe I don't have it. I've opened too many tabs, but yeah, we have documented all the metrics that are there, but we are also interested by the feedback, because it's a new tool and we still need to discover the best way to use it efficiently. So all feedback is very useful. It's in preview for the moment. So if you have a performance problem in production and you reproduce it in a lab, you can reproduce it in the latest preview version and get more information.
Yeah, this is necessary. This is extremely important especially for the day 2 operations. Once in production, you want to know the details. Profiling and all those low-level metrics are extremely important. They will help you just to. I know that because usually, I'm happy that Yuga by DB continues investing into this, because not every startup company starts investing into this in the beginning, but you have to do that. because it's important for customers.
And the age in active session history means that we have an history. So usually when users complain about performance, they don't complain about the database now. They complain about my query this morning was slow. So you have all information to troubleshoot something that happened in the past.
Okay, nice. So I think that's the wrap for our quick update. It's summer. Keep an eye on our events. We have a bunch of online events, we have in-person events, and we keep creating interesting content. Just go to our blogs. Also, subscribe to Franck's Dev2 account, because Franck publishes many times a week on the personal blog and also on LinkedIn. Give a follow and stay in touch. Now, going to our multi-region design patterns for high availability and disaster recovery. So this topic is, we want to focus on multi-region deployments first. This is when you decided to use multiple cloud regions or multiple data centers. And you can use that for various reasons. You can use it for performance or compliance, etc. We will be talking about high availability and disaster recovery. And now let's probably, Franck, start with the end of this title, with high availability and disaster recovery. So usually, even I sometimes have to remind myself, because when it takes, let's say, when I like one day I remember, but then a half a year later I still need to. If you don't use those terms regularly, you open up, the definition and you remind yourself what's the difference between high availability and disaster recovery.
I think it has always been a very long discussion, and people have different ideas about it. My experience about high availability and disaster recovery, so the definition I have from my experience, because I've been working a lot with Oracle database. Oracle has rack, where you have clusters that share the storage, and this is for high availability. If one server is down, then everything continues. But on a single cluster, you cannot stretch that many kilometers away. And disaster recovery is more, a disaster. The database center burns. So your multiple servers in one cluster burn all together. So you need another solution far away, so that the fire that doesn't go in the two regions or two data centers.
Mm-hmm.
And far away means latency. And then you have to do something differently, because when you are really close and you have a network with low latency, you can replicate synchronously, and then you are sure that you have no data loss for the most frequent failures, like network down, a server down, whatever, maintenance, patching. But if you go many kilometers, like into countries or even further, you cannot wait 100 or 200 milliseconds at commit. So you need to do something asynchronous, where you may accept to have some data loss because you didn't wait on each commit. But anyway, if a whole region is down, if a whole data center is down, maybe you can afford to miss a few transactions in the last seconds. And this is really a scenario of disaster. And also one big difference, high availability can be automated because you have no data loss, so you can automate. When you have data loss, even if it's small, usually you have a human decision, because you need to understand what happened. If the data center burns, then you can fail over to another region, because the data center will not come back. If it's just a network problem, maybe you can decide we do not fail over immediately to avoid data loss. We just wait that the network is back. So it's a human decision, because you need to know what happened in the data center, and the system doesn't know because it cannot communicate with it. So those are my two definitions. But I can add something. That was in Oracle. In traditional databases, other databases don't really have the equivalent of Oracle RAC. And then they call high availability something that is more like disaster recovery, but more synchronous with more automation. And then those terms are used for similar things, high availability or disaster recovery, just thinking that one is faster than the other. But we will see that in Yugabyte, we have also those two different solution for the two concerns. And yeah.
Exactly. What how I try to remember the definition of two. When it comes to high availability, for me, the goal of high availability is to run system in such a way that it eliminates a single point of failure.
Yeah.
So if there is no any single point of failure, like let's say there might be some glitch, one of the servers can go down, but pretty much the system is designed for such a way that no, all those glitches, you assume that the system will fail, and you want it to be highly available. That's why just eliminate single point of failure. Don't have just one single primary writer. Don't have a single application instance, right? If you want to have single application instances, think about several fault domains. Don't deploy all those application instances on a Kubernetes node that is running on one rack. Just deploy across on different database, on different, let's say, Kubernetes machines. Do something like that. So just no single point of failure. If you don't have it, then you will be highly available, but this high availability, we measure it in what?
It's resilient.
Yeah, resilience.
And for me, it's not even recovery, because you don't have anything to fail over, recover. It's just continuous.
Yeah, continuous operation, because you manage to avoid having a single point of failure. You don't have it. And this is especially important for.
It's like if you have two network paths between the data center, which you should do, or just having two switches or whatever, you don't say that you have a recovery. You are just resilient to one failure, fault tolerant.
Yeah. When it comes to the disaster recovery, as you say, it's basically the process of getting system back to normal operations. This is the plan, and this is your architectural solution that brings your application to normal. You know that the worst thing had happened, and now you need to follow this plan. You need to follow this process. It can be semi-automated, fully automated, or just manual stuff. But you're accepting that you might have some data losses, you might have some longer recovery times, etc. But this is the disaster, and everyone understands that this is the disaster. And right now we are dealing with that. So this is the disaster recovery. The thing is that when you try to combine these two terms, high availability and disaster recovery, and then you have those multi-region applications or multi-region database deployments. What used to happen, at least in the past, and I saw this frequently, many companies try to achieve high availability within a single region or within a single data center, meaning that they might have several racks or they might have several availability zones within a region, and they were trying to achieve high availability across multiple zones or across multiple data centers in a very close proximity. And they used to do this. What I saw frequently is that from the latency standpoint, because if the zones are nearby and if any zone goes down, I'm in good hands, which means that I'm highly available on the zone level. And many disaster recovery plans that I looked at, they were designed for region level outages or for the data center meltdowns, like you, Frank, mentioned, and the company didn't have any secondary data center nearby. They just had, let's say, a data center that was hundreds of miles or kilometers away, just hundreds and sometimes thousands of miles or kilometers away. And they would have disaster recovery for those scenarios, and they would be using different techniques like asynchronous replication at the database level, right? And they would accept something like that.
Yeah, in the cloud, high availability is within a region, between zones within a region, and disaster is between region. Then the cloud has also came with its own definitions.
Yeah, this is interesting. At the same time, when you run your application, at least within a single cloud provider, the network is very optimized, and there are regions that are far away from each other and close enough to each other that you still can run a configuration of your application and your database across multiple regions. And if you do that, pretty much you solve your high availability and disaster recovery at once, meaning that if you want to tolerate at least one region level outage, you will be highly available, because if you have a database and application running across multiple regions, synchronous replication across multiple regions, then you're in good hands. But with Yugabyte, if you're using Yugabyte, you need to have 3 regions at least, because you want to have a replication factor of 3. And not everyone needs this, right? As you, Frank, said, you had many conversations with folks who have only 2 regions or 2 data centers, and they don't have any reason.
Yeah, especially on premises. In the cloud, it's quite easy to have 3 data center because you just deploy in 3 availability zones. But companies, there are many companies who have 2 data centers close or in different regions, but 3 data center, there are not a lot of companies with that. Well, I've been working a lot in Europe, and I know that in Europe it's not the case. I know that in Asia it's not the case. Maybe in US there are bigger companies with more data centers. I don't know.
Yeah, exactly. So now let's discuss. Let's see some of those design patterns in practice. So, folks, what we would like to show you today, maybe we'll show 2 configurations. Frank will take over the scenario when you have two regions, 2 cloud regions. So think 2 data centers that are located far away from each other, and you will be highly available within those regions, right? But when it comes to the disaster recovery, one of the regions will be primary, and there will be a synchronous replication process between those 2 regions. For the scenarios when the primary region goes down, your primary database instance goes down, and then you need to do the switch over to the secondary one. So we will show you how to achieve this with Yugabyte. And what I will do in the end, I will show you a different approach. We will be using 3 cloud regions in the United States. Those regions will be spanning across the country. And I will show you how to achieve both high availability and disaster recovery if you have 3 regions and you want to use a multi-region Yugabyte DB cluster. So we will be discussing the Raft consensus protocol, synchronous replication. So this is the flow. This is the plan.
Okay.
Let's go, Frank.
So let me share my screen and explain what I will do and do it. So I have two Yugabyte cluster there. They have nothing in common except that I've created with the database as a service platform that we have, Yugabyte Anywhere. So I can see them in the same screen, but they have nothing in common. They are in 2 regions. One is in Europe, the other is in US. As you mentioned, here for the lab, I have only 1 node in each one, but in production it will be multiple nodes because it's not deciding DR or HA, is HA in each region and then DR on top of it. But for the example, I've just created one. The nice thing with this database service tool is that it shows the price, and that's also the reason why for a lab, when you don't need more nodes, it's just easier to provision a simple cluster. So I have 2 new. Let me just show one. I have no tables.
And while you're navigating there, just to highlight, because I think this is important, even though Frank uses Yugabyte DB Anywhere today, we selected it because we wanted to show you, we wanted to use like a very simple to use interface, just to do the switchover, to show the replication lag, etc., etc. But underneath, we are running, we are using the X cluster, transactional X cluster asynchronous replication of Yugabyte, which is open source, meaning that even though we are showing you a paid product today, we are doing this for the sake of operational simplicity. But if you would like to use a fully open version of Yugabyte DB for the same stuff, you just can do it on your own. And you just need to find a way how to monitor and do the switchover on your own.
All the features are in the database, and that's open source. The automation, we put it with support because it also helps support if the customers who have support use the same tool, the same automation, that it's much easier to provide support on it. So let me connect to them. So on top, I am in Europe, and here I am in US, and I have nothing for the moment there. And I will just create some tables using pgbench. Sorry, I pasted 2 times there. So this just creates some tables with some warning, but that's not That's not a problem, just because it notice something about alter table that is not the recommended, but this is I'm using pgbench, not the Yugabyte version of pgbench there, but that works. I have my tables, I have small data on it, and of course I have nothing in the other because I didn't create anything in the other. That's the goal.
And the other one is secondary, meaning that it's going to be used in case if their data center in Europe fails.
For the moment, the second one has nothing, and I will replicate to it. So let's run also some workload with pgbench. That's the idea. I'm running a workload for the next hour and showing every 5 seconds the transaction per second there. So I have some load, and now from the UI, I will create the replication just because it is easier. I can see that. Sorry. I just have to log again. Let me find my cluster there. Yeah, I'm there. I can see the node here. I can see the tables. And we have this X cluster disaster recovery. So it means cross cluster because we will replicate across 2 clusters and for the purpose of disaster recovery. I will run it, and while it runs, I will explain maybe the difference, what is special doing that with disaster recovery. So
generally speaking, X cluster is this asynchronous replication feature that we have in the open source product.
And that can be used for different things. Disaster recovery is one of them. So let's configure it. I started it in my cluster in EU, and I want to use another one. So let's find the other one there.
Okay,
that's also the advantage of using the database as a service. The database as a service has a repository that knows all my databases, all clusters.
And this actually Yugabyte DB anywhere. This is something that you can run in your own data center or cloud environment because you have Yugabyte DB managed, and I will be using Yugabyte DB managed today. This one is fully managed offering by Yugabyte. Yugabyte DB anywhere is when you also want to take this management and observability, etc. capabilities and run on your own premises. And you want to have your DBAs, you want to have your DevOps to work with the Yugabyte DB clusters.
So what is nice with cross-cluster is that you have, it's not all or nothing. You can select some tables and you can select one database. You know that in a cluster, like in Postgres, you can have multiple databases. Best practice, you create a database for application. I didn't do that, so I have only the default Yugabyte there. And I select it and I confirm the full copy just because it has to copy the data first and then replicate. And to copy it, we are in the cloud. We will go through S3, and I think that's also something we are default. No, okay.
No, I need to
Let me just find it. So that's also something with the databases service. It knows not only about the databases, but also the S3 buckets where you can do your backups and you can use it to transfer the data between 2 regions.
And while this initial copy is taking place, your application keeps running, right? The application is not impacted.
Yeah, the application is running. So the idea is that it will copy the data, so in the background, and then it will synchronize it with the logs, basically, because we have the log. Everything is every changes are going to the logs. They are replicated through Raft, and they are also used for change data capture and for the cross-cluster replication. So we have this intermediate level between the SQL layer and the distributed storage, DocDB. We have this intermediate layer where all the writes are key value logs about what is written or what is logged or some metadata or whatever, and everything is there. Different kind of replication, but all using the same idea. So the initialization copies the data, and this is what we are seeing. And and it's
and
just
actually, try to execute, my friend, try to execute /d on your secondary cluster. I think that the schema should have already been created.
Because I have timeout on the connection, so I already have the tables. Let me.
So this is actually good because you don't need to. Certainly, you might have DDL files with hundreds or thousands of database objects, and when you do this initial, when the xcluster_dir makes this initial backup copy, it also will be recreating the schema on the secondary cluster. You don't need to.
Yeah, so it was fast. Now it's already done. My tables are not so big, so.
Yeah, try to refresh. Actually, okay, it
is enabled, so I can see that I'm replicating there. By default, all the tables, I can remove some of them if I want, because it's really per table. And you can see the lag, you can see the size, so it's really per table. And here it is just replicating. So if I select, sorry, I have it somewhere just to copy paste. It's always easier. So I can select
Let's do the watch.
The sum here, and it changes just because my application is changing there. So it is replicating from one cluster to the other. But now I need to explain what is special about disaster recovery.
Yeah, could you please, you see this potential data loss on failover? This is the lag actually.
Yeah.
If you also scroll down below, you will find the graph.
Because it is asynchronous, so you know that you can have some data loss, but you need to know how much. Even if the primary region is not accessible, your decision to activate the disaster recovery will depend on the data loss. Of course, if you have a few milliseconds, because in case of a failover, I will have to warn the user, be careful, we had a big disaster, we had a flood of fire in the data center, and then just be careful, maybe the last transactions within the past minutes are lost. Well, it's just milliseconds. You see the latency. This is about the latency between Europe and US. But
which is fair. But also, can you say, like, even let's say, even if I lose those last updates, the database on the secondary still will be in a consistent state because our
exactly
just finish it.
And this is why the metrics we have the asynchronous replication lag, but we have also the safe time. And because we scale everything, that's a big difference with even logical replication in Postgres, for example. Postgres has a single stream of write-ahead logging, one for the whole database, because it's monolithic. Here, each table, even each tablet, has its own replication. And this means that they all send their write-ahead login in parallel to the target. So it's better for performance and it's better to scale, but means that on the target, they may not be all at the same time. When you have only one whole stream, then you know that the whole database advances at the same pace. So this is what we do for disaster recovery. Cross-cluster, by default, just replicates each tablet without caring about the consistency between the different tablets. But for disaster recovery, we need consistency. And this is, so one difference, cross-cluster can replicate in two ways, but then you don't have consistency, because if you do asynchronous in two ways, it's last write that wins, so you cannot. So first, when you replicate for disaster recovery, you have a primary and you have a standby where you can do only read-only transactions.
Okay, so now.
And also it keeps tracks of the safe time. So this point in time where it knows that if you query as of this point of time, then everything is consistent. And it's easy to query as of a single point in time or just to point in time recover to it, just because we are MVCC database, multi-version history, so we can go into the retention. So that's the thing. Even if the replication itself is if the lag is just a few milliseconds, the save time may be a bit more. Here it was about 1 second at the beginning, and then it's slower.
And then it also will depend on the volume of your on the volume of your write workloads, how many changes, and you certainly can fine tune this replication. Plus, you can minimize this replication, like if you, let's say, don't need to replicate across the Atlantic Ocean, but probably just across several data centers in Asia or Europe or United States. But what's important here, because I remember that those users who need to run who need to implement the DR for this 2 data centers or 2 region strategy, the biggest problem for them was data consistency if, let's say, the disaster happens. Because the data lag is not a big deal. They already accept the fact that there will be some data loss, but the data loss will be in a sense of, let's say, some of the transactions were not replicating, but whatever was replicated is fully consistent. And
you don't want to corrupt your database. You can accept that you have a few transactions to redo. Tell the user that maybe what you have entered in the last minute, you have to enter it again. But yeah, you don't want to corrupt it. And then, so that we have 2 metrics. We have the save time, which is basically the difference between the current time and the last consistent time. So of course, if the network cuts, then the save time will increase. And we have also the save time skew, which is the difference between the minimum and the maximum, because they all send their replication. So there is a few milliseconds between them. So it's a way to just control that everything works. But also, if you need to fail over, then you know exactly how many transactions you have lost. But of course, if you take the decision to fail over even after 1 hour, maybe you know that the data center, the primary data center, was not available because it has burned. And then you know that you don't lose 1 hour of transaction because nobody was able to enter transaction on a burning data center. So
from the user standpoint, let's just one last example, and then we can go to this failure scenario. From the user standpoint, let's say that Frank wanted to transfer some money to me using PayPal, right? Because I have a birthday and Frank wants to give me some money. And actually, what happened? Let's say if we did not have this transactional asynchronous replication, that what could have happened? Frank's account would be withdrawn $100, and that information would be replicated to the secondary data center. But then let's say the disaster happened, and the second part of the transaction, when the money have to be debited to my account, then it was never executed. And if this is the big problem, because when you reconnect to the secondary cluster during the disaster, you have this inconsistent state. Someone like, we took money from the Frank's account, but I never received those accounts.
And it's difficult to solve, even to test.
Yeah, but in this case, let's say with Yuga by DB, I mean, if let's say this happened, that the money was withdrawn from Frank's account, the information was replicated to the United States, but the debit information about debit in my account was not replicated yet. The disaster happens. This withdrawn from the Frank's account will not be applied on the secondary data center. So it will, like on the secondary data center in the United States, it will look like the money was never taken from Frank and they were never, let's say, given to me, which is expected.
Yeah, and something else that I'm just showing. So I mentioned that it's one way, and of course, to avoid corruption, we also must ensure that nobody will update the target that is in standby. So if I try to do something that changes data, I can query data on the target. But if I try to modify data, that it tells me that modification is forbidden. So yeah, to stay safe. And maybe instead of a failover, which we can do to test, or because there is something, I will run a switch over and explain the difference while it is running. Because it's not only about disasters. Maybe you want to do some maintenance, or maybe you want to distribute the load differently. You realize that you have more customers in US than in Europe, and then you want to put the primary database in Europe. So the switchover reverses the role of the two clusters. One was the primary and the other was the read replica, and now I reverse it. So of course, my application here has failed because now on the primary, I can only query. And here, if I reconnect.
Yeah, this is kind of a planned failover, planned outage when you want to do this from the maintenance standpoint,
Yeah.
or like as you said, you just want to reverse, their who is primary and who is not.
Okay, so here I just wanted to do the same to show that I can delete the data on the new primary. Of course, I for constraints, so I cannot. But yeah, now the old one is the read replica. The old primary is now the read replica, and the new one is in Europe. So just and yeah, the important thing, if you do a failover, you have some data loss. But if you do a switchover, it takes care to drain the sessions before shutting down the primary. So you have no data loss here. My sessions on the primary were cancelled, killed, just because it became read-only. But it waited that everything are replicated so that the save time is really the current time before opening it. So switchover has no data loss. That's something you can do just because you want to do some maintenance on one region and you have no data loss. You can do it fully online.
Yeah, and with Yugabyte DB Anywhere with this X-Cluster DR feature is just a button click. You don't need to come up with your own scripts or whatever. Just let the tool knows how to work with the underlying database instances.
Yeah, and doing some checks. When you do a switchover, you want it to be safe. So it can take some time just to be sure that everything is replicated. And yeah, it needs to be safe. So now I think I have to refresh to see the new configuration where the replication is in the other way. And oh yeah, US to EU. Okay.
Yeah.
So yeah, that's what I was showing for the cross-cluster disaster recovery, and then you can show something else.
Yeah, let's do this because for the switchover, if you folks interested, just let us know. I recorded a video because Frank demonstrated switchover. I also recorded a video that shows how to do the failover, that button, right, that Frank you had on the X-Cluster DR. For that, you need to emulate an outage in the region, and then you do the failover. You will be having the data loss, meaning, and the data loss depends on your replication lag. So I think that yeah, we'll share this video. Reach out to us. It's nice, and we have a blog post on this. Now, that was for 2 data centers, and we used asynchronous replication between the clusters for the DR. When it comes to 3 regions, and this is something that is contemporary for databases such as Yugabyte, you can use, if you have 3 regions, then you can take advantage of the Raft consensus protocol. Because if you configure your database cluster with the replication factor of 3, meaning that at least you need to have 3 copies of the data in different locations, then according to the Raft, if at least 2 locations can come to an agreement on an update, then you will have a consistent copy. So which means that even if you have, let's say, if you have 2 data centers, 2 regions in the United States East and 1 region in the United States West, then you can run a single database cluster across the country. But if you use the Raft consensus protocol, two regions that are in the United States East, they will be able to commit your transactions much faster. They don't need to wait for the acknowledgement from the West, just because this is how the Raft functions. And still, with this configuration, if any of these regions goes down, you will have no any data loss, because this is the Raft synchronous replication. You will only see higher latency for your write requests. But that's the disaster situation, right? When you have a loss over entire data center, this is disaster, and you expect to have, let's say, some higher latencies for your applications. Let me show my screen right now.
Again, so the big difference is the number of data centers. With two data centers, you cannot do that, because if the network between the two data centers fails, either you cannot be synchronous, because then you lose all availability. If you are synchronous between two data centers and the network in between fails, then the primary cannot go further, cannot accept writes. So you need at least three, so that you have a quorum, and then you have fault tolerance to one region, one data center down, where it can continue.
Exactly. So what I created, again, the configuration that I'm going to discuss, you can reproduce it using the open source version of the database. I'm using Yuga DB managed. It's just database as a service in Azure, AWS, or GCP. I deployed my 3-node cluster in Azure. I have 3 nodes. And if I go to the nodes tab, you will find that every node runs in one of the regions of the country. I have a node in the United States West, in Phoenix, Arizona, and I have another node in the United States East, Virginia, and there is another secondary data region in Virginia that is far away from this one. And I decided to go with this configuration because why? I will be able to tolerate region level outages, and still, as long as two regions are close enough to each other, I will have quite low write latency. You will see what that latency is. The replication factor is obviously 3, meaning that when I will be executing my write requests, where I go to the settings, I think it should be here, total 3 nodes or somewhere else. At least, let's say two nodes, 2 data centers needs to agree on the transaction. So it runs here, and I have a virtual machine in Azure. What I did also, if you will be deploying using Yuga DB managed, you can expose your database cluster to the entire world. I just usually decide to take security into consideration. I set up private connection endpoints. So generally, my application instance can connect to any of these nodes, and this is private connection endpoint. Now let me connect to this machine and run my application workload. I think, let me check if this is the machine. Yes, I'm connecting to this machine, user, and this is my certificate. Yeah, for some reason I decided to update this Fig manager. Now it's always okay. So my application, it's here. It's not PageBench. It's a market orders application. What it does, it connects to a remote service that generates market orders. Companies sell and folks sell and buy different stocks on the New York Stock Exchange, and I'm actually going to capture this mock data, it's fake data, and then I will be processing this data and storing it into my multi-region Yuga DB cluster. This is what I want to do. And when I'm storing this data about the market stock purchases or sales, I want this data to be replicated across regions, and I don't want to lose it, and I want to tolerate region level outages. How to start this application? This is just a simple Java app. I'm starting this jar file, and I will be using these properties. Let me show you the properties first, how it looks like. Properties, Yuga DB properties. So here is, this time I decided to use the Postgres JDBC driver. It's not our smart driver. It's just, let's say I created this application for Postgres, and then I want to migrate it to Yuga. And this is my database address, connection address. I'm using, again, the same Postgres driver. And when you connect with Postgres, I'm telling that by default, connect to this United States East location. Why to this location by default? Because this is my primary node. Let me show you here. Preferred region, meaning that even though I have 3 copies of my data across all those regions, the primary copy will be stored in this location. So all the raft leaders will be placed and located on the database nodes from this location, which means that by default it makes sense to connect here if you want to achieve the lowest latency. However, I also expect that a bad day can come, and if, let's say, this location, this node becomes unavailable, please connect to their other node that runs in the United States East 2 cloud region. And if this one fails, please make a connection to the West US3. This is what's supported by Postgres.
So you use the host list.
Yeah, exactly. And this is the password, folks, that you don't need to see. But anyway, I will stop these instances shortly. Okay, so let's start this application workload. I created the schema. I connected, and here, as you can see, some summary, some statistics. This is, how many trades do we have in our database. And this application instance is also located in the United States East, and it's connected to my database node from the preferred region in the same location. So that's why the read latency, take a look, is just 1 millisecond. It's nothing, because we are located in the same region. Probably different availability zones, but still within the same region. The write latency, let's take a look at it. It's quite good. It's like 14 milliseconds, 18 milliseconds, 13 milliseconds. But remember that this is the write latency for synchronous replication. It's not asynchronous, it's synchronous replication. Before every transaction gets committed, it needs to have at least 2 copies of the data, because we use Raft. And the latency is not 65 milliseconds, because the latency between East and West in the United States is 65 milliseconds, but the latency is much lower. What's the trick? As I said, I decided to optimize the write latency as well. As long as I have 2 regions that are quite nearby in the United States East Coast, the latency between these 2 regions is, I think, around 14 milliseconds or 12 milliseconds. That's why when you execute a transaction, the Raft consensus protocol needs to wait for the acknowledgement from the nodes from these 2 locations. And this one will eventually kind of get it committed. So that's the latency. Now,
and 40 milliseconds, it's something that the user doesn't perceive. Of course, you need to have the right design for your application, not updating to many rows. But yeah, that's something for a transaction that is okay, 40 milliseconds.
Yeah, this is what this transaction done. This is a simple insert. I can show you folks the source code. This is a simple application. If I go to this market order stream, I'm capturing this message from this remote service, and then I'm just doing this insert. And this insert needs to be consistently committed across 3 regions. And as long as we use Raft consensus protocol, we don't need to wait for the acknowledgement from the United States West. As long as this transaction is acknowledged by the nodes in the United States East, we are good to go, and we are consistent. So if now let's simulate an outage. Let's say that we had some meltdown, some catastrophe in the United States East region, first one, in our preferred one, and see what happens. How I do this? As long as I'm using Yuga by DB Manage, there is no any direct way to connect to this DBAS and stop your database node, but there is a trick. We have APIs. You can create your own tools. If you go, let's say, to, I think, securities, you have your API keys. So you can use Terraform, you can use REST APIs to work with your cluster. And this is exactly what I'm going to do. So I want to stop. I will be emulating this outage by stopping this node. And this node runs in the United States East. My command looks, how does it look? As follows. I'm making this HTTP post request to Yuga by DB Managed. This is my account. This is my project. This is the cluster. And I'm asking to stop this node. So node number 3, yeah, this one. And once this node is stopped, I will no longer have any other nodes in the United States East in my preferred region, and that's going to be an outage. Okay. Yeah, looks like it successfully executed. Let me see if I have anything happening here. Yeah, you see that we are stopping the node. It's not abrupt termination, because you cannot have this abrupt termination on Yuga by DB Managed unless there is a real outage in the cloud. But it's stopped. And here, let's take a look. the latency increased. The write latency increased for my application, but if you scroll up,
so the application continues. It's just that it takes a bit more time.
Yeah, so here as you see, like that was the time when the United States East was operational, and then suddenly the East went down. I don't have any exception in the application level, but right now the latency is higher, much higher, and the read latency is higher. Why? Because my application automatically connected to the database node in the United States East 2. And the application instance runs in the United States East, which means that for reads and writes, it also needs to send requests across the regions. But then when it comes to write, now the nodes in the United States East 2 and West 3, they have to come to consensus, to agreement. That's why the write latency is higher. But remember, this is the disaster. This is the situation where that should not happen, but it happened, and at least you're operational. You still might get some exceptions, because some of my, I think that my connections, all of the connections of the application were open to the failed region, right? And in my application, I was catching different SQL exceptions, and I was saying that if an exception transaction was terminated, and this is obviously what happened, I was just retrying their transaction. I was retrying this transaction. I have this, just for the sake of experiment, I have this while true loop. And you need to do the same in your application, especially if you use the repeatable read isolation level. Just catch your exceptions, because some of the connections
I cannot hear you. I don't know if it's my network or yours. If someone can tell us in the chat if you still hear us or not. I don't know who has lost the network. I think I'm still there. So if you can tell me in the chat if you can hear me. And maybe Denis has lost the connection. Something that I can mention, if it's Denis that is off and I'm still live. No, okay, I'm disconnected. No, Denis has disconnected. Okay, so if you are still there, what I can mention there, Denis explained that if you are connected to the node that fails, yeah, okay, Pete, tell me that you can hear me. So perfect. I continue. What I will explain is that if the application is connected to the node that fails, then you lose the connection, and we cannot be resilient to that. But in real life, this disaster happens when a whole region is down. So if the whole region is down, probably the application there is also down. Usually when you deploy this kind of deployment multi-region, you have in each region some database nodes, but you have also the application server in each region, so that in each region, the application server connects to the database node in the same region. And then if the whole region is down, say the data center has no power for 1 hour, then of course the database nodes are down, but the application there also. So you need this retry only if some nodes in the regions are down, but if the application goes, then you lose the connection. Denis, did you disconnect more than your database?
Like when did you lose me? What was I showing?
you was just explaining that you was showing the codes where you retry the transaction.
Okay. Yeah. It's like, generally my Wi-Fi is down. I live in Florida, and right now this is a hurricane season. We might have some storm. I don't know what's happening. So those Wi-Fi outages
and we have Andre telling us that Denis should use Raft. And also, actually, we did Raft, because when I didn't see you, I didn't know if it was my connection or your connection. And then I asked, and then Pete told us, can hear you. And then we have the quorum. If I have an answer, then I know it was you that was out of the quorum. because we are free. When we are only two, we cannot know which one has a problem. we need a third one.
A good example. A good example. Nevertheless, that was emulation. I think that at least folks you saw. What happens next? You just bring back. If you want me to quickly finish this setup, let me share my screen. What I can do is,
and also saying hi to Eshwa.
What I do is I can execute in YugabyDB managed. I can execute this post command, and this is, and here is I'm asking, please start this node, please restore my database node, and eventually it will be restarted, and then your application will get to so-called normal operations when the latency will be much lower, and there will be no disruption because the application will be committed now to the preferred region that is back to normal, and the latency will be not 100 milliseconds for writes, but it will be again around like 14 milliseconds for writes. Okay, so that's it. Outage was a setup. No, yeah, the question.
No, we didn't plan that. We just used it to explain Raft, but yeah.
This happened to me, twice. I remember I had another I had a technical tech talk when we had this. When after Yugabyte was used for the Super Bowl event in the United States, we had a detailed technical talk when I was showing how to achieve, let's say, low latency across multiple regions, and I also failed. I had some my laptop froze for the first time.
But that's current IT. We are not anymore running on an isolated data center where we have high-end switches and network. We are running through the cloud, and here we are streaming through the cloud, and failures can happen, of course.
All right then. So folks, we already reached the end of our stream, but nevertheless, we always can stay for extra 5 minutes. So more if you have any questions. And in the meantime, Frank, anything else you'd like to add before we go?
Just making sure that everything is clear. We were talking about DR, but two solutions for DR, which really depends on what you want to achieve, how many data centers you can have, what are your performance criteria. It's all things that you have to decide. For example, in your demo, you were showing that with a failure, it continues with higher latency. Some business prefer that, having a service that still works even if it's slower. Some other business may prefer to stop the service rather than having longer latency. Some business accept to have some data loss and restore the service. Some other prefer to wait that the service is back. So many different situations. The goal is not to make the database complex and the solution complex. It's just because there are different usages, but they all use the same technology in a different way. We replicate the same thing, we just replicate it differently.
Yep. That's a wonderful point. Yeah, because even though, let's say, I showed this demo in the end, it doesn't mean that you're encouraged to use only this deployment option, because like this high latency might not be unacceptable, right? You're operational, you're highly available, nothing happened to your application workload, but that 100 plus millisecond latency can violate SLAs, and that can be treated as a disaster, as a huge incident. Just think about, let's say, some trading application or financial application when the latency is crucial. So probably in that case, then you're accepting to lose the latest updates that you can figure the last updates that were not committed, fully replicated, but you're just quickly switching your applications. You have the downtime that lasts, let's say, for some time you're switching, but you always have the good low latency for your application instance.
So
up to you.
We were mentioning different definitions for high availability, and another one is just that does it fulfill the SLA that you provide to your customers or not?
Exactly. You need to think about this. SLA is very important. This is your commitment to your customers and to the services you sell. All right, we don't have any questions. which means that we are ready to wrap it up. Thanks a lot for everyone who joined us today, and we hope that you liked it. And those who watched us on demand and watched till the end, also thanks for making this happen. If you want us to show something else specific in practice in this hands-on way, you know where to find us in the community Slack or Twitter, LinkedIn. Just say hi.
Or YouTube, because the recording is on YouTube and you can also leave comments there.
Yeah. Okay, we've got a question from Andre. Do you have a custom conflict resolution strategy for a multi-master to region deployment?
Good question. So this is cross-cluster that you don't choose for disaster recovery, but for two-way replication. For the moment, we don't have conflict resolution strategy. Well, we have one that is very simple. The last write wins. So basically, you don't want to write, update the same rows on two nodes because it will break the acidity. And if you use Yugabyte with the Postgres compatible API, probably you care about the acid properties. So it is not recommended. You can use cross-cluster in two ways when you know that you do not update the same data sets from the two ones. So for example, you do multi-tenancies and you can distribute the load like that. Your application connects to one region for some tenants and to the other from some other. If you have a workload where last write wins is okay, then you can do it. But my experience, but I've also always been working with SQL databases. My experience is that when you break the ACID properties with two-way replication, you will have more problems than the solution it brings.
Yeah, hope it answers your question. We know, like actually, Andre and myself, we know each other really well.
Okay.
Yeah, the last time we met, it was a year ago at the DevNexus conference in Atlanta. Hope to see you soon, Andre, some other place. Hope you're doing well. Thanks for joining us today. All right, then. So, folks, have fun and good luck. And thanks for watching us today.
And see you next time.
Sure.